In this video, I will explain ensemble learning and decision trees and with their implementation in Python. In simple terms, decision trees are like decision-making flowcharts. A decision tree is a simple yet powerful tool used in machine learning. Imagine it as a flowchart with questions at each step. You start at the top, and based on the answer to each question, you follow it down to a decision at the bottom. Decision trees are like a series of yes or no questions that help you classify things or predict outcomes. Decision trees are easy to interpret and very useful in decision making process. Whereas ensemble learning is about combining multiple machine learning models to make better predictions. It's like asking a bunch of friends for their opinions and then making a decision based on what most of them think. In machine learning, these friends are different algorithms. By letting them work together, you can reduce errors and increase accuracy. One popular type of ensemble learning is the random forest, which combines the predictions of many decision trees, resulting in more robust and accurate results model. Let's illustrate this by creating a simple example using a hypothetical dataset of individuals' heights and weights to predict whether they play basketball or not. This is a binary classification problem. In this example, we've generated a simple dataset of heights and weights, and we are using a decision tree to classify whether individuals play basketball or not based on their height and weight. Interestingly, decision trees can be used to classify non-linear data like neural networks, as illustrated in figures. But in real world, data is often complex and ambiguous, and we cannot make decisions in simple hierarchical manner by creating a decision tree as illustrated here with breast cancer Wisconsin diagnostic data set. Let's implement indication tree and random forest in Python. We will use random forest to improve decision trees classification performance. We will first import required packages and load dataset. For model validation, we will split the data into 80% of training and 20% of testing sets. We will now create decision tree and random forest classifier using instance of scikit-learn tree and ensemble class. The models now can be used to predict the class labels of test data. We can now create a confusion matrix to understand classification behavior. We can observe here 4 malignant samples were misclassified as benign, and similarly 3 benign samples were misclassified as managed using Dixon tree. Whereas in case of random forest, only 3 malignant samples were misclassified as benign and 1 benign samples was misclassified as malignant. Let's just create classification performance report to have a sense of our classification model. We can observe 2 to 3% higher accuracy in case of random forest. That is it for now. Thanks for watching.